So yesterday we saw that we did 3 iterations on one problem. We noticed that our answer that we got was pretty close to what the actual solution was supposed to be, right? Um, so today we're going to kind of continue, do some problems where maybe our answer comes out exactly what it should be, and then maybe see one example where you notice that it's not working for us. But we're going to start off with example number 2 here. We did one yesterday. It says use Newton's method to approximate the zero, or zeros, I guess, of f of x equal to 2x cubed plus x squared minus x plus 1. Okay, so if you guys remember, the formula looks like this. X sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. So that means I need my derivative. So let's find the derivative here. F prime of x is equal to 6x squared plus 2x minus 1. Okay, so thank you. So there's my derivative, there's my original function, there's my Newton's method formula, right? Now, they do tell us, oh, I forgot to write this in the main problem. Up here, put let your initial guess, x sub 1, equal to negative 1.2. So they told us, here's your initial guess. Notice they didn't tell us how many iterations or anything like that. But they said, make sure your initial guess is this. Now, I'm going to write in blue again, just to continue instructions. I'm going to put, make sure the final answer differs by 0.0001. So that's pretty accurate. So in other words, you're going to keep doing iterations again and again and again until you're within that error. Okay? So we already have our original function. We have our derivative. I've already calculated all the derivative values, so we're just going to kind of go through this quickly. But normally what you would have to do is get your values, put them into the derivative function and stuff like that. I'll write it down, but I'm going to save us the time of actually having to calculate it. So here we go. X sub 1 is negative 1.2. Remember, this is not an iteration. This is the guess, okay, or the initial estimate, whatever you want to call it. Now, x sub 2 is negative 1.2 minus f of f of negative 1.2 divided by f prime of negative 1.2. Okay, that's what x sub 2 is supposed to be. It's supposed to be x sub 1 minus f of x sub 1 divided by f prime of x sub 1. That looks like this, negative 1.2 minus 0.184 divided by 5.24. Okay, so that means that x sub 2, once you calculate all that stuff, is negative 1.23511. Now, if we check the error to see if we're done, because if it happens to be less than or equal to 0.0001, then we're finished. So we're going to do the absolute value of x sub 2 minus x sub 1, which would be negative 1.23511 minus negative 1.2. Well, that equals to 0.03, etc. That's not close enough, right? We need to be within a 10,000ths. We're at a 300ths right now, so that's not good. So we got to do it again. So let's find x sub 3. For x sub 3, we're going to use the answers of x sub 2, so the negative 1.2 1.23511. So negative 1.23511 minus f of negative 1.23511 divided by f prime of negative 1.23511. Like I said, I already did the calculations just to save us some time. So this is negative 1.23511 minus, it's negative 0.007706. I do write a lot of digits because I'm trying to be accurate, since I need my accuracy to be in the 10,000s, right? So I'm just leaving a lot of digits there. And then on the bottom, it's 5.68276. And this is equal to negative 1.23375. So to check the error, I'm going to take x sub 3 and subtract x sub 2, right? So x sub 3 minus x sub 2, which is negative 1.23375 minus negative 1.23511, which is equal to 0.00136. So the error is getting closer. We're now at approximately 1,000. We need 1/10,000, right? So let's do this again. So again, notice we don't know when we're going to stop doing this. It could be 12 iterations. It's based on your guess. If your guess is bad, you're going to be doing this for a long time. But if your guess is good, you might get it on the 3rd try. Maybe you might get on the 4th try. So let's go with x sub 4 now. And I think it works after the 4th. Yeah, the 4th will be fine. So x sub 4, x, would be negative 1.23375 minus f of negative 1.23375 divided by f prime of negative 1.23375. So the calculations were already done, so here's what we get. Negative 1.23375 minus, now f of negative 1.23375 is 0.000011 divided by 5.66533. And when we calculate that, we get negative 1.2335. So when you subtract x sub 4 minus x sub 3, yeah, it's a 0. Well, you can't get more accurate than that, right? There's no error. So when they say find the 0, we just found it, right? So the 0 is found at x equal to negative 1.23375. Again, the amount of work that you do is based on your guess. If your guess is bad, you might be doing this for a while. If your guess is good, it might take 2 or 3 iterations. Okay?
Can you go back to the Thomas?
Yeah. Like where? Like the main instructions?
Yeah.
Yeah. So notice I gave you a good guess because I don't want to waste our time here for 30 minutes trying to figure out one answer, right? So I gave us a decent guess. How did I figure out that decent guess? I actually graphed it before to see what the answer was supposed to be, and then I picked the value. Like I said, I do want you guys to do the same thing. Graph it, and then check what the answer is, and pick something really close to it so that you guys aren't doing 15 iterations. Okay? Try not to be too perfect on it, because then if you are, then you, after one iteration, you get it done immediately. At least try to do 2 iterations. So don't be too exact, but you can be close. Okay?
This be a multiple choice or
Usually these are going to be multiple choice type questions. Yeah. And some people, like, what they normally do is they'll try to get these things. It's an easy thing to memorize, so just try to keep it in your head. That way, you just use the formula right away instead of having to generate this whole stuff. So it should be okay. Now, there are situations where this stuff doesn't work. Okay, so let me show you this last example, and then we're going to talk about the conditions for convergence, and then we're done. But this last example here, example number 3, and this kind of shows us two different things. It says using x sub 1 equal to 0.1, show that Newton's method. So show that Newton's method fails to converge Now remember, when they say converging, that means that the answers are trying to approach a specific point, right? That's what convergence means. Divergence means that they're just going far apart from each other. There's no pattern that's going to get them close enough, right? So show that Newton's method is going to fail to converge for f of x, bless you, equal to x to the 1/3. Okay? Now, let me show you something that you can always do whenever you're doing these types of problems. And we didn't do it with the previous one because it doesn't work in that case. It's too big of an equation. But whenever you have small equations, we know we have this f of x, x of n sub 1 is equal to x sub n minus f of x sub n over f prime of x sub n. Now the derivative, let me do the derivative right here under it. F prime of x will be 1/3 x sub n to the negative 2/3. Okay, that's the derivative of, I'm sorry. Let me get rid of the sub n for now. That's the derivative for f of x. Okay, so what I'm going to do is I'm going to plug those equations into Newton's method. So x sub n plus 1 is equal to x sub n minus f of x sub n would be x sub n to the 1/3 over, and then f prime of x sub n would be 1/3 x sub n to the negative 2/3. Okay, now why am I going to do that? Well, look at the denominator and the numerator in that fraction. Since they're the same base, that means I can actually subtract their power. So 1/3 minus a negative 2/3, that's actually a 1, right? So x sub n minus, I'm going to write 3 x sub n. Because the 1/3 in the denominator, you flip it over, it becomes 3 over 1. Now, x sub n minus 3x sub n is equal to negative 2x sub n. So notice, Newton's method, I altered it a little bit. I didn't break any rules. I just kind of put my original equation in there, and I said, well, can I write this equation in an easier way so I don't have to keep, putting in all these derivatives and all this stuff all at once? Can I simplify it? So I did. So there's my new Newton's method formula for this problem. Okay, so I know that x sub 1 is 0.1. So x sub 2 would be negative 2 times 0.1. Okay, which would be negative 0.2. And then x sub 3 would be negative 2 times negative 0.2, which is 0.3. Okay, x sub 4 would be negative 2 times 0.3, which would be negative 0.6. Look at these numbers on a number line, okay? So, our first one was 0.1. By the way, this is not to scale. And then negative 0.2. And then 0.3, and then negative 0.6. Are these answers converging? No, they're getting further and further away, right? If you calculate their errors, the errors are getting larger and larger and larger. Okay? So when we do this, actually, you know what? I just realized I did something incorrect in this calculation. That should be a 0.4, right? And this should be a 0.8. I just saw that right now because 2 times 2 is 4, not 3. Sorry about that. But as you keep doing that, like the next one would be a positive 1.6. The next one would be a negative 3.2. After that, it's a positive 6.4. The numbers aren't getting closer. They're getting further and further apart. Okay? When you notice that, that means that this thing is diverging. It is not converging. Okay? So we're going to say that no limit exists. It's not going to one place. Okay? So no limit exists for this thing. And if you were to look at the graph, okay, if you were to try to look at the graph and see what happens, it would look something similar to this. Let me show you a real quick sketch. Whoops, that's not a good sketch. Where is it at? No, I want that right there. So the function kind of looks like this. So if I tried 0.1, I'm gonna zoom in real quick. If I try 0.1, then the tangent line would take me here, okay? And then if I tried the next point, the tangent line would take me a little further. So I know I'm not doing it great. I'm sorry about that. But if I go to the next one, that tangent line would take me out a little further. And then if I go to this next one, this tangent line would take me out a little further. So that's basically what's happening. Every single time we found a point and drew its tangent line, it would keep getting further and further apart. So like, for example, this line is going to be like way over here. The next line is going to be way over here. The next line is going to be way over there, right? It's just going to keep going further and further away. It's just a big mess if you look at the picture. But the tangent line's taking it further and further away from the actual zero. Does it have a zero? Yes, it does. It has a zero at 0, 0. But if I use Newton's method, it doesn't work for this one. Because it's just the way the curve is. The curve doesn't fit it properly. So it doesn't mean a zero doesn't exist. It actually does. But just not for this situation. In this case, yeah, you would actually have to try to figure it out. And actually for this one, it's easy enough to find the zero, right? But yeah, in the other case, it was just tougher because the zeros, the way the curve is angled and stuff, it doesn't allow the tangent lines to get closer. They keep going further apart. So that's why. So how do you know then? Because I don't want to waste my time doing this and then all of a sudden I find out, oh, it's because it didn't work. And I'm over here doing like 10 iterations of this stuff, right? So how do I figure out if it's going to work? So there's a condition for convergence. So if you want to check before you do all the work whether or not it's worth doing the work, okay, then this is the formula you use. It's not an easy looking formula. You use f of x times f double prime of x divided by f prime of x squared. And that has to be less than 1 on an open interval containing the zero. I'll show you an example of how we do this. Okay? So let's look at the one that we just did, okay? The problem that we just did. So example number 4. Show that Newton's method fails for f of x equal to x to the 1/3. So I already have my original function. I can take my derivative, f prime of x is 1/3 x to the negative 2/3. And then I'm going to take my second derivative, f double prime of x is, what would that be? A negative 2/9 x to the negative 5/3. Okay, now what I'm going to do is I'm going to put all these terms into that formula, f of x times f double prime of x divided by f prime of x squared. So here we go. F of x is x to the 1/3 times f double prime of x, that's negative 2/9 x to the negative 5/3 divided by the first derivative, 1/3 x to the negative 2/3 squared. All right, so let's start simplifying this. I mean, this is just algebra, right? So absolute value of x to the 1/3 times x to the negative 5/3, that's x to the negative 4/3. So negative 2/9 x to the negative 4/3. And then on the bottom, 1/3 x to the negative 2/3 squared, that'd be 1/9. And then that's x to the negative 4/3. Because it's when you square a negative 2/3 squared, it's when you take a power to a power, you multiply, right? So it's negative 2/3 times 2. So it'd be negative 4/3. Now notice you can cancel this, right? So that means that this now is basically negative 2/9 times 9/1, which is absolute value of negative 2, which is 2, which is not less than 1. Okay? So that's how you can find out if it's gonna work or if it's not gonna work. Okay, now remember example 1, we had just so you could see a real quick recall here. To show that it would work, this was example 1, right? F of x equals to x squared minus 2. Okay, and we knew our answer was within, what was it, 1.412, no, 1.414 something, right? We found out that was our 0 exactly, but that's where we were at. Let me just show you this. Let's take the first derivative of this because it's an easy one to do, right? There's my first derivative, and then my second derivative. Okay? Now, let me do the process of checking to see if it would work. So, it's f of x, so x squared minus 2, times f double prime of x, that's 2, divided by f prime of x, 2x, quantity squared. Well, if I simplify this, I get 2x squared minus 4 over 4x squared. If I simplify it a little bit, I could break it apart. I get, this would be a 1/2 minus 1 over x squared. Now notice this one didn't cancel out like the other one, right? It didn't become like, oh, it's -5 and that's less than 1, so great. We didn't get something like that. So, or sorry, not -5, -0.5. So this has to be less than 1. How do I prove it? Well, when you look at the definition, it says for an open interval that contains 0. If you graph this function and look at it, let's say within that interval, because they say just find an open interval that contains your answer. And we know our answer is supposed to be 1.4, well, radical 2, right? Supposed to be radical 2. Radical 2 is found within 1 through 3. If you look at its graph between 1 to 3, you'll notice the values for y within 1 through 3 will be less than 1. So you want to look at the graph. You'll be able to confirm that by looking at the graph. Okay? So let me stop it here. Let me just show you the graph real quick. But let me stop it real quick. All right, so the equation is up there. It's the one in red. Let me make this projector friendly so it can be a little better for you guys. You can see that y equal to 1 represents the value of 1. And anything from 1 through 3 on the x values is less than that blue line. It's below it. So that means that the function must converge between those points. Okay? And remember, all you got to do is choose any interval that contains the answer, and you want to prove that it's less than 1. Okay? So I got to figure out the coding thing for that other one, but I'll do that at a later time. So, all right, let me give you guys the homework for that, and we are done. All right, so there's the homework for this assignment.